You've heard the phrase a million times, right? That forests are the lungs of the earth. They breathe in all that CO2 and breathe out the oxygen we all need to survive. And look, it's a great image and it's not wrong, but what you probably don't know is that it's only half the story.
What if I told you our planet doesn't just have one lung, but two, and that the second one, the one that's arguably even more powerful, is almost completely hidden from view? Well, over the next few minutes, that's exactly what we're going to do. We're going to uncover the other half of our planet's respiratory system.
So where is this hidden lung? It's the ocean. Yep, that massive blue expanse covering more than 70% of our world is also a gigantic oxygen-making machine. It's kind of the unsung hero in all of this, and we're really just starting to get how important it is.
Okay, so just how much oxygen are we talking about here? Scientists estimate that a whopping 50% of all the oxygen on Earth comes from the ocean. Think about that. 1 of every 2 breaths you take right now comes from the ocean. This isn't just a little helper, it's a core part of what keeps us all alive.
So who's doing all this work down there? It's not some kind of giant underwater tree, but microscopic life. Yeah, all this heavy lifting is done by tiny drifting organisms we call plankton. They're like these invisible forests of the sea, and they're doing the exact same life-giving job as the biggest tree you can imagine. And you know, even among these tiny powerhouses, there's one that's a total superstar. Meet Prochlorococcus. It's this tiny little bacterium, the smallest photosynthetic organism on the planet. But get this, it's responsible for making up to 20% of the oxygen in our entire biosphere. One single type of bacteria. It's just wild. To really put that into perspective, this one species of bacteria produces more oxygen than all of the tropical rainforests on land combined. Just let that sink in for a second. The Amazon, the Congo, all those huge, dense jungles, they are being outproduced by a microscopic organism floating in the ocean. So you might be wondering, how can two completely different systems, a giant forest and a tiny bacterium, do the exact same vital job? Well, it turns out they share the same magical biological engine, photosynthesis. Let's take a quick look at how it works. At its core, photosynthesis is basically nature's alchemy. It's this incredibly elegant process that takes 3 simple ingredients, sunlight, water, and carbon dioxide, and turn them into 2 absolutely critical things, energy in the form of sugar, and for us, the happy byproduct of oxygen. You can think of it like a 2-step recipe. In step 1, the plant or plankton uses sunlight to literally split water molecules apart. That's the exact moment oxygen gets released. Then, in step 2, it uses the energy from that process to grab CO2 from the air and turn it into sugar, which is the fuel for life. This exact same recipe, this fundamental piece of code, runs in both of our planet's lungs.
Okay, now that we get the engine, let's circle back to our planet's more famous lung, the forests. Here's the thing, in today's world, both lungs are also huge carbon managers. But while the ocean is quietly absorbing incredible amounts of CO2, it's the forests where this whole process is the most dynamic and frankly where it's most at risk right now. This quote from the World Resources Institute just nails it. It's not just about sucking carbon in. Forests also release it when trees burn or decay. They're constantly managing this massive flow of carbon, back and forth, like a two-way highway. And the sheer scale of this is pretty mind-blowing. As you can see, forests pull a massive 16 billion metric tons of CO2 out of the atmosphere every year. But, through deforestation, fires, and just natural processes, they also release about 8.1 billion back. The number that really matters for the planet is the difference between those two. And that difference is a net absorption of 7.6 billion tons of CO2 every single year. I mean, what does that even mean? Well, to put it into perspective, that is 1.5 times more carbon than the entire United States emits annually. This service that forests provide is a massive brake on climate change. But here's the catch. Not all forests are doing the same job. The Congo Basin in Africa, it's still a really powerful carbon sink, which is great. But the Amazon is teetering on a dangerous tipping point where it could start spitting out more carbon than it absorbs. And tragically, the forests of Southeast Asia, thanks to plantations and fires, are already a net source of carbon. So let's pull this all together. We have 2 lungs. One is made of water, the other of wood. Both are absolutely essential, both run on the exact same photosynthetic engine, and unfortunately, both are facing some pretty serious threats. The threats look different, sure, deforestation versus algal blooms, But they often have similar origins, and these systems are deeply connected. For example, when fertilizer runs off deforested farmland, it can pour into the ocean and trigger those massive algal blooms that suck all the oxygen out of the water, creating huge dead zones. We're not just damaging two separate things, we're messing with one big, interconnected life support system.
And that really brings us to the final, crucial question. Once you realize our planet has two lungs, it completely reframes the challenge, doesn't it? It's not just about saving the rainforest. It's about protecting the entire planetary breathing system, from the tiniest bacteria in the sea to the tallest tree on land. The real question is no longer about which lung to save, but how do we make sure both of them can keep breathing life into our world?